An ice fall from another star system just past Venus, 97 million kilometers. November 3rd, 2025. The internet called it an alien mothership. Scientists called it the most carbon dioxide-rich comet ever measured. Social media said it was hiding behind the sun to deploy probes. The data says something stranger. 3i Atlas is real. The measurements are real. What does that November 3rd flyby actually tell us? Strip away the hype. Look at what the telescopes caught. This is the documented story of an interstellar visitor that broke every prediction we had. Discovery came fast. July 1st, 2025, Atlas telescope at Rio Hurtado, Chile, observatory code W68, a moving dot at magnitude 18. Distance from Earth, 3.50 astronomical units. Distance from Sun, 4.51 astronomical units. Speed, 61 kilometers per second relative to the Sun. The object sat on the border between Serpens Cauda and Sagittarius, right near the galactic plane. Temporary designation, A11PL3Z. The Minor Planet Center got the observations within hours. Follow-up observations started immediately. Professional and amateur astronomers. By July 2nd, 3 different observatories, Canada, France, Hawaii Telescope, Lowell Discovery Telescope, Deep Random Survey in Chile all saw the same thing. A marginal coma, a potential tail like elongation 3 arcseconds in angular length. Not an asteroid, a comet, active, outgassing. July 2nd, 2025. The Minor Planet Center made it official. Interstellar Object Designation 3I, third confirmed interstellar object. After 1, Oumuamua in 2017. After 2, Borisov in 2019. By the time the name stuck, 122 observations from 31 different observatories. David Jewett and Jane Liu confirmed it with the Nordic Optical Telescope. Clearly active, diffuse appearance, but it arrived with a problem. Pre-discovery observations pushed the detection back. Zwicky Transient Facility caught it June 28 through June 29. More images, June 14th through June 21st. Atlas itself had images June 5th through June 25th. Sam Dean, amateur astronomer, found those. The comet passed in front of the galactic center. Dense star fields, hard to discern against billions of background stars. NASA Transiting Exoplanet Survey Satellite had images going back to May 7th through June 3rd. 6.4 astronomical units from the Sun, already bright, already active. That distance meant the activity could not be water ice sublimation, something more volatile, carbon dioxide. The measurements would prove that later. If you value documented interstellar astronomy and compositional analysis like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. Also, this script is researched and factual, using sources from the August 25th part, 2025 paper titled JWST Detection of a Carbon Dioxide-Dominated Gas Coma Surrounding Interstellar Object 3I Atlas, published in the Astrophysical Journal, Letters, preprint archive as Arxiv 2 508.18209 DAS, and the Wikipedia article for 3I Atlas, which aggregates observations from 31 observatories and was last updated November 5th, 2025. Now back to the information. The orbit told the real story. Eccentricity 6.1. Hyperbolic, not bound to the sun. Trajectory tilted 175 degrees. Retrograde, inclined 5 degrees to the ecliptic. Moving backward through the solar system relative to planetary motion. Maximum speed at perihelion 68 kilometers per second. 137,000 miles per hour. Fastest velocity ever recorded for a solar system visitor. The math traced it backward. Came from interstellar space, billions of years drifting. Gravitational kicks from stars and nebulae accelerated it. The Milky Way thin disk, or thick disk, if thick disk, the comet could be 7 billion years old, older than the solar system itself, 4.6 billion years for our system, 7 billion for this wanderer. That age came from velocity analysis published by researchers studying its galactic trajectory. Size became the first debate. Early July estimates said 10 to 20 kilometers diameter. Astronomers knew that was wrong. The coma brightness overwhelmed the nucleus. Hubble Space Telescope imaged it July 21st, 2025. Distance from Earth, 277 million miles, 446 million kilometers. The images showed a teardrop-shaped cocoon of dust, plume ejected from the sunward side, hint of a dust tail. Background stars streaked because Hubble tracked the moving comet. Analysis from those images, August 20th, 2025. Upper limit 5.6 kilometers, lower limit 320 meters. Most likely, estimate less than 1 kilometer. Dust loss rate, 6 kilograms per second of small particles. Ejection speed, 22 meters per second for 1 micrometer grains. 2 meters per second for 100 micrometer grains. The Vera Rubin Observatory caught pre-discovery images June 21st through July 3rd. Coma diameter grew from 13,040 kilometers to 18,760 kilometers in 11 days. Growth rate documented. Activity increasing. Then Sphere X observed August 7th through August 15th, 2025. Distance from Sun, 3.2 astronomical units. Distance from Earth, 2.6 astronomical units. 3 wavelengths, 3 micrometers for water. 4.26 micrometers for carbon dioxide, 4.7 micrometers for carbon monoxide. Water, not detected. Upper limit, 4.5 kilograms per second. Carbon monoxide, not detected. Carbon dioxide, bright symmetric cloud. Extended to at least 348,000 kilometers radius. Brightness declined with distance to the power of negative 3/2. Density declined with 3-dimensional radius to the power of negative 2.5. Mass loss rate, 70 kilograms per second of carbon dioxide. The 1 micrometer flux suggested nucleus diameter 46 kilometers if typical albedo 4%, but if 99% of brightness came from icy fragments in the coma, nucleus diameter dropped to 5 kilometers. Either way, mass exceeded 33 billion tons, 1,000 times the mass of 2I Borisov, estimated at half-kilometer diameter. James Webb Space Telescope joined August 6th, 2025, near-infrared spectrograph. Distance, 3.32 astronomical units from Sun. Spectral images, 0.6 to 5.3 micrometers. Result, shocked astronomers. Carbon dioxide dominated the coma. Carbon dioxide to water mixing ratio 8:1, among the highest ever observed in any comet. 4.5 sigma, above the trend for long period in Jupiter family comets, excluding outlier C 2016 R2. The spectrum showed 129 kilograms per second carbon dioxide emission, 6.6 kilograms per second water, 14 kilograms per second carbon monoxide, 0.43 kilograms per second carbonyl sulfide. Water ice, grain size less than 1 micrometer, likely amorphous ice. Crystalline ice could not be ruled out. Swift Observatory detected tentative water vapor and hydroxyl radicals July 31st and August 1st. Suggested water ice grains sublimating beyond the nucleus. Distance 4,000 to 10,000 kilometers from nucleus. Published in the Arcs of Preprint August 25th. Authors Martin Cordner and 12 others. Very Large Telescope observed July 20th through August 21st. Ultraviolet spectrum. Nickel emission lines grew over time. Cyanide emission lines grew over time. First nickel detection, July 20th. First cyanide detection, August 14th. By August 21st, emission rate 4.6 grams per second nickel, 17.6 grams per second cyanide. Concentration similar to solar system comets at similar distances, but one anomaly, no iron vapor detected. Nickel and iron typically appear in equal amounts in cometary outgassing. 3. I Atlas showed nickel without iron. That pattern matched industrial production of nickel through the carbonyl chemical pathway. Nickel tetracarbonyl, a volatile compound. Breaks into carbon monoxide and nickel under solar ultraviolet. Published observation, documented measurement. No speculation added. Trajectory brought close planetary approaches. Mars, October 3rd, 2025. Distance 0.19 astronomical units. 28 million kilometers, 18 million miles. ESA ExoMars. Trace gas orbiter photographed it. Color and stereo surface imaging system. Fuzzy white dot moving downward. Coma visible. Nucleus unresolved. 10,000 to 100,000 times fainter than usual targets. Exposure time 5 seconds. Mars. Express tried with 0.5 second exposure. Too brief. Object too faint. Did not appear. But ExoMars caught it. Evidence preserved. Then perihelion. October 29th, 2025, 11:27 UTC. Closest distance to Sun, 1.36 astronomical units, 203 million kilometers, 126 million miles. Between Earth and Mars, orbits, solar irradiance 770 watts per square meter, maximum thermal stress, maximum activity. Solar conjunction. October 21st, object directly opposite Earth with Sun between, unobservable from ground telescopes. GOES 19 weather satellite imaged it during conjunction. Punch constellation satellites imaged it. October 14th. Processing by Thomas Lehman and Marshall Eubanks. SOHO, and stereo spacecraft tracked it through coronagraphs. Stacked frames showed coma diameter 4 arc minutes. CCOR-1 frames, Shy-1 imager, SCOR, 2 coronagraph, LASCO C3, all captured the passage, hidden from Earth. Visible to space assets. November 3rd, 2025, Venus approach, distance 0.65 astronomical units, 97 million kilometers, 60 million miles. Not a close pass by planetary encounter standards, but closer than Earth would ever get. Earth closest approach, December 19th, distance 1.80 astronomical units, 267 million kilometers, 168 million miles. Safe distance, no threat. Venus passput. 3I Atlas in position for ESA Jupiter Icy Moons Explorer observations. JUICE spacecraft, November 2nd through November 25th. Multiple instruments, headed toward Jupiter. Positioned for favorable line of sight, early November, using primary antenna as sun shield. Data transmission delayed until February 2026 to protect instruments. But observations made, recorded, waiting. Mars closest, Venus next. Jupiter March 16th, 2026, distance 0.36 astronomical units, 54 million kilometers, 33 million miles. Juno spacecraft could image it. Radio antenna could check for transmissions. Technological signature search, protocol established, data collection planned, social media erupted, mothership claims, mini-probe deployment theories, alien surveillance speculation. Harvard astrophysicist Avi Loeb published multiple papers. Posted to Medium, appeared on Fox News. America's Newsroom, October 29th. Discussed with Bill Hemmer and Dana Perino. Called 3I Atlas Potential Trojan Horse. External appearance natural comet. Interior potentially technological. Cited 8 observations. 1. Rapid brightening exceeding most Oort cloud comets. 2. Nuclear glow without typical cometary activity patterns. 3. Extreme negative polarization unprecedented for known comets, including 2 I Borisov. 4. Arrival time allowing close passes to Mars, Venus, Jupiter, while unobservable from Earth at perihelion. 5. Gas plume with much more nickel than iron. 6. Gas plume only 4% water by mass. 7. Unexplained trajectory alignment. 8. Arrival direction within 9 degrees of WOW signal location. Published papers calculating delta V requirements for planetary intercepts. Venus, less than 5 kilometers per second before April 2025. Mars, less than 5 kilometers per second until end of July. Jupiter, less than 5 kilometers per second through November. Low thrust budgets for trajectory changes. Oberth maneuver optimal at perihelion. Maximum energy efficiency during solar conjunction when unobservable. Probability of random trajectory alignment with Venus-Mars. Jupiter close approaches calculated at 0.005%, 5 in 100,000. Published in paper accessible at Harvard Center for Astrophysics. Authors Haki Misra, Loeb, and others. But observations supported natural explanations. Chi-Cheng Zhang of Lowell Observatory and Carl Battams of U.S. Naval Research Laboratory published ARXIF preprint late August. Rapid brightness, surge on approach to perihelion, data from space-based instruments. Extrapolated perihelion brightness, 9th magnitude. Considerably brighter than original forecast. Suspected cause, visible gas emissions. Expected to emerge from solar conjunction considerably brighter than entry. Cause, identified, carbon dioxide, sublimation. Cooling effect of vaporizing carbon dioxide ice held water, ice vaporization in check as comet approached sun. Then carbon dioxide depleted enough for water activity to surge. Predicted pattern for carbon dioxide, rich objects. 2 mechanisms proposed for high carbon dioxide ratio. First hypothesis, intrinsically carbon dioxide-rich nucleus. Indicates ices exposed to higher radiation levels than solar system comets during formation. 7 billion years in interstellar medium. Cosmic ray bombardment, ultraviolet from nearby stars. Second hypothesis, formation outside carbon dioxide snowline and origin system. Region where not only water but carbon dioxide stays solid. Either way, natural formation. Documented in other systems, rare but explainable. Composition analysis showed Earth-like carbon isotope ratio. Carbon-12 to carbon-13, similar to terrestrial values. Indicates similar formation chemistry. Molecular cloud composition, comparable to solar system progenitor. But environmental difference is clear. Higher ultraviolet exposure or colder formation region. The very large telescope spectrum matched. Carbon dioxide dominance, nickel without iron. Cyanide presence, all fit volatility sequence. different formation conditions, not impossible conditions. Observations by Gemini South August 27th captured 0.5 arc minute-long tail, bright condensed nuclear region, temporary atmosphere of gas and dust, standard cometary features, active sublimation, normal physics. The Nordic Optical Telescope observations, July 2nd by David Jewett team. Diffuse appearance confirmed, activity confirmed. Coma structure typical, dust grain analysis showed reddish color, similar to D-type asteroids, similar to solar system comets, similar to 2I Borisov, caused by irradiated organic compounds, tholins, complex molecules formed by ultraviolet and cosmic ray processing of simpler organics, common in outer solar system, common in interstellar medium, expected for old object. Ground-based observations resumed November 3rd. Magnitude estimated 10, uncertainty high, comets dynamic. Perihelion passage dramatically affects light curves, visible 2 hours before sunrise. Close proximity to Venus in sky. Close proximity to Spica, brightest star in Virgo. Observing conditions improving from that point. Comet fading as it receded from sun. First half of November, ideal for long exposure imaging. Coma details, tail structure, constellation Virgo. Early morning object, telescope required. 8-inch minimum for dark sight visual detection. Smart telescopes with 3 to 4.5 inch aperture successfully imaged it. Total magnitude 12 as of October 3rd, 120 times fainter than Comet C 2025, a 6 Lemon. 190 times fainter than Comet C 2025, OSR 2 Swan at that time. Never bright enough for naked eye, never bright enough for 70mm binoculars. Apparent magnitude 11.5 peak predicted, below visual threshold for average observer. Amateur astronomers contributed. Thomas Puzia of Pontificia, Universidad Católica de Chile led team. Observed with Very Large Telescope, SOAR Telescope, ALMA Radio Telescope. 3 PhD students, Rohan Rahat Gaonkar, Juan Pablo Carvajal, Baltasar Luco. Quote from Puzia: "We are working overtime for this once-in-a-lifetime opportunity. We balance dissertations and responsibilities, but right now our compass points to one thing, 3I Atlas. When the universe whispers, you answer." First paper, published end of August. Another in review with preprint available. Deep infrared observations, high-resolution spectroscopy, detailed compositional analysis, published. August 23rd image showed early tail detection, rare opportunity. Interstellar object in exquisite detail, first chance since 2I Borisov. Only third confirmed visitor, knowledge window closing, object leaving forever, NASA missions coordinated observations, Hubble multiple times, Webb August 6th, Spherics August 7 through 15, Swift Observatory July 31st and August 1st. TESS pre-discovery May 7th through June 3rd. Mars missions, Perseverance, Mars Reconnaissance Orbiter, Curiosity Rover, Parker Solar Probe, Europa Clipper, Lucy Spacecraft, Psyche Spacecraft, Punch Constellation, ESA NASA SOHO, ESA JUICE, International Coordination. Maximum data collection, every instrument pointed, every wavelength scanned, infrared, visible, ultraviolet, radio, every spectrum analyzed, never again, once through, one shot, trajectory hyperbolic, escape velocity exceeded, leaving solar system permanently. After Jupiter Pass, March 2026, acceleration outbound, back to interstellar space. 7 billion year journey continues. Where next? Unknown. Trajectory traced back 10 million years by team led by Xavier Perez Cudo, University of A Coruña, Spain. Used Gaia Space Observatory star position data, sought origin star, sought perturbing encounters, path reconstruction showed galactic thick disk origin, vertical extent into outer disk clear, sun stays near galactic plane, 3I Atlas orbit extends far from plane, ancient object. Old formation, long journey, no origin star identified, too many candidates in that direction, galactic center region, billions of stars, impossible to pinpoint single source, peak activity data came from multiple instruments, coma size at maximum from Spherics, 348,000 kilometers radius, carbon dioxide cloud, Earth diameter, 12,756 kilometers, carbon dioxide cloud 54 times Earth diameter, visible only in infrared, bright emission lines, symmetric distribution, sunward enhancement visible in Webb data, jet-like feature pointed towards sun, enhanced outgassing on heated hemisphere, standard cometary behavior, rotation likely present, but period not determined. Dust tail extended 56,000 kilometers on August 27th. Measured at distance 2.59 astronomical units from Earth. 30 arcseconds angular length. Math checks out. 2.59 AU times 30 divided by 20626. 5 equals 56,353 kilometers. Documented, measured, verified. Coma, angular diameter, 2 arcseconds, full width, half maximum. 10 arcseconds, full extent. Small on sky. Distance effect, actually enormous in physical size, comparable to largest solar system comet Coma's. Orbital evolution, tracked precisely. Inbound velocity, 61 kilometers per second on discovery. Perihelion. Velocity, 68 kilometers per second. Gravitational acceleration from Sun. Standard physics. Outbound velocity decreasing from perihelion value. Still exceeds escape velocity. Hyperbolic excess velocity calculated. After leaving solar system influence, returns to roughly 61 kilometers per second in interstellar frame. Trajectory refined continuously. As of November 5th, 2025, ephemerides updated daily. JPL Horizon System. Public data. Anyone can track. Sky position predictable. Distance calculable. Brightness estimates uncertain but improving. Every observation refines parameters. Orbital elements. Epoch, July 18th, 2025. Julian date 246087.5. Source, JPL Small Body Database. Perihelion, distance 1.356193 AU. Eccentricity, 6.128. Inclination, 174.99 degrees. Argument of perihelion, 298.1 degrees. Longitude of ascending node, 258.6 degrees. Time of perihelion. October 29th, 11:27 UTC. These numbers define the path, predict the future, confirm the past. Brightness evolution showed surprises. Zwicky Transient Facility, data from Chi-Ching Zhang and colleagues. Plateau phase May 15th through early June. Constant effective size, no growth in reflecting area. Then uniform brightening phase, steady increase, growth factor 5 to 10 during plateau. If plateau represents bare nucleus before mass loss, actual diameter 15 kilometers, 20 times larger than 2, I. Borisov, 8,000 times more massive if same density, creates statistical problem. Why one 15-kilometer object before thousands of half-kilometer objects? Interstellar rock reservoir cannot supply 15-kilometer objects frequently. Once per several millennia rate implied. Tension with detection statistics. Alternative explanation, plateau artifact of measurement error, star contamination checked. None found. Error bars larger in that period. Uncertainty acknowledged. Debate continues. Diameter somewhere between 320 meters and 46 kilometers, depending on assumptions. Albedo, uncertainty. Coma contribution, uncertainty. Nucleus, brightness, separation, uncertainty. Final answer requires direct imaging. High-rise camera on Mars reconnaissance orbiter proposed. High-resolution capability, could resolve nucleus. Direct measurement of reflected light. Size determination without model assumptions. Observation window limited. Request submitted. Priority evaluated. Results pending. Venus flyby. November 3rd, created observation window. ESA JUICE spacecraft positioned favorably. Distance 64 million kilometers from comet on November 4th. Slightly greater than Venus past distance, but better geometry for spacecraft instruments. Multiple instruments planned. Imaging, spectroscopy, plasma measurements, particle detection, magnetic field monitoring. Goal: detect any plasma interactions. Measure any charged particle flux changes. Search for bow shock signature if comet ion tail intersects spacecraft path. Low probability, but non-zero. Data stored on board. Antenna configuration prevents real-time transmission. Sun shield mode for instrument protection. All data downloads February 2026. Mission timeline constraint, but observations made. Permanent record, historical documentation. Venus itself, no observations. No spacecraft at Venus currently. No ground observations possible. Venus, too close to Sun from Earth perspective. Morning object, but low altitude. Twilight sky. Comet magnitude 10 to 11. Venus magnitude -4. Angular separation small. Contrast overwhelming. Practical observation impossible. The November 3rd distance, 97 million kilometers. 2/3 of 1 astronomical unit. Not intimate, not threatening, not unusual. Comets pass planets at such distances regularly. Solar system comets, long period comets. This one interstellar. That makes it special. Distance and date unremarkable except for context. Statistical analysis of trajectory published by team at Harvard and University of Washington. Calculated probability of close approaches. Venus within 0.65 AU, Mars within 0.19 AU, Jupiter within 0.36 AU. All three occurring on single trajectory with 5-degree inclination. Probability 0.005%. 5 in 100,000, cited as evidence for non-gravitational acceleration, possible trajectory adjustment. Alternative explanation, observational bias. We detected this object because it entered inner solar system. Inner solar system has planets. Planets distributed in ecliptic plane. Retrograde trajectory crossing. Ecliptic guarantees planet encounters. Selection effect. We see the ones that come close. We miss the ones that stay distant. Bias inherent in detection method. Statistic meaningful only with prior probability for interstellar object visit rate. That prior unknown, population unknown. How many interstellar objects pass through solar system per year? Upper limits exist, lower limits uncertain. Estimates range from 1 per decade to hundreds per year depending on size threshold. 3 detected in 8 years, 2017, 2019, 2025, sample size 3. Statistical significance weak. Conclusion premature, more detections needed. Vera Rubin. Observatory now operational. Legacy survey of space and time beginning. Detection rate will increase. Within 5 years, expect dozens of detections. Within decade, expect hundreds. Population statistics will improve. True trajectory distribution will emerge. Then we will know if 3I Atlas unusual or typical. Composition provided strongest science. Carbon dioxide dominance. 8-to-1 ratio versus water. Never seen at that level in solar system comets except C 2016 R2, statistical outlier. 2I Borisov showed 2-to-1 carbon dioxide to water. 3I Atlas 4 times higher, implies formation in carbon dioxide, rich environment, or preferential water loss. 2 scenarios. First, origin system molecular cloud had high carbon to oxygen ratio. Produced carbon monoxide and carbon dioxide preferentially over water. Planetary system formation in such environment yields carbon-rich planets. Carbon-rich comets, possible but rare. Metallicity and composition variations exist between stellar populations. Thick disk stars show different abundance patterns than thin disk stars. 7 billion year age places formation in thick disk era. Different galactic chemistry, different available materials. Second scenario, water depleted by radiation processing. 7 billion years in interstellar medium. Cosmic rays, ultraviolet from chance stellar encounters, preferentially removes water. Water more easily photodissociated than carbon dioxide. Long exposure time, significant loss possible. Leaves carbon dioxide enriched surface. Deep interior might still be water rich. Surface composition, not representative. Surface samples not representative. Only perihelion heating reveals interior. October 29th passed. Activity peak passed. Observations continuing. Surface layers ablated. Next layer is exposed. Composition changing as sun strips outer material. By December, different layer visible. By March, at Jupiter, even deeper layers. Time evolution of composition tells formation story. If carbon dioxide ratio drops, surface enrichment confirmed. If stays constant, intrinsic composition confirmed. Watch the curve, track the ratio, data will answer. Nickel emission remains anomalous. 4.6 grams per second, no iron. Nickel to iron ratio infinite. All other comets show equal nickel and iron. 50-50 split, standard metal vapor pattern. 3 I Atlas breaks pattern. Hypothesis 1, nickel tetracarbonyl formation. Nickel plus carbon monoxide at low temperatures forms volatile compound. Sublimits easily. Carries nickel to coma. Ultraviolet breaks molecule. Nickel released. Iron does not form similar compound. Iron stays in nucleus. Nickel appears without iron. Mechanism documented in industrial chemistry. Mon process for nickel purification operates at 430 Kelvin. Comet nucleus temperatures in that range at 3 AU from sun. Chemically plausible, naturally occurring. No technology required. Hypothesis 2, differentiated interior. Nickel-rich layer exposed. Iron-rich layer deeper. Ablation reveals stratified composition. Meteorite analogy. Iron meteorites versus stony iron meteorites versus nickel-rich camosite. Composition depends on parent body differentiation. Comet nucleus could have layered structure. Formation history created separation. Natural process, not impossible. Hypothesis 3, original formation deficiency. Molecular cloud locally depleted in iron, enriched in nickel. Supernova enrichment patterns not uniform. Nucleosynthesis produces elements in ratios. Ratios vary by supernova type. Type 1A produces more nickel. Type 2 produces more iron. Molecular cloud composition reflects contributing supernova. Local variations exist. Possible, but requires specific history. All three hypotheses natural. No technology required. No violation of known physics. Anomalous, but explainable. Polarization measurement added another puzzle. Observations showed extreme negative polarization. Negative means reflected light polarized opposite to scattered light expectation. Normal comets show positive polarization. Light scattered by dust grains polarizes perpendicular to scattering plane. 3I Atlas showed parallel polarization, unprecedented for comets including 2I Borisov. Cause unclear. Dust grain properties, size distribution, composition, shape, alignment, something different about the dust, could be grain size. Submicron grains produce different polarization than micron-sized grains. Web data confirmed small water ice grains, less than 1 micrometer. Small grains alter scattering. Could explain polarization, could be composition, organic compounds, tholins, carbon-rich materials, different refractive index, different scattering properties, could be shape, fluffy aggregates versus compact grains, porous structure versus solid structure, affects light interaction, all natural possibilities, strange but natural, or could be alignment, magnetic fields in coma, elongated grains align in field, polarization direction rotates, unusual but possible. Comet passes through interstellar magnetic field, picks up field orientation, dust aligns, polarization reflects alignment, testable hypothesis, requires more data, polarimetry from multiple angles, time evolution, wavelength dependence, measurements continuing, puzzle remains. Answer pending. The WOW signal connection drew attention. August 15th, 1977, Big Ear Radio Telescope, Ohio State University, 72-second signal, frequency 1.420 gigahertz. Hydrogen line, 6 times background noise. Came from direction RA 19H25M, deck minus 27 degrees. Sagittarius, never repeated, never explained. 3I, Itlis, came from direction RA 19H17M, deck minus 23 degrees. Sagittarius, angular separation, 9 degrees. Same general region. Lobe highlighted coincidence, asked if connection possible. Time gap, 48 years. Distance light travels, 48 years, 48 light years. Sphere of 48 light year radius around Earth contains roughly 400 stars. Those in Sagittarius direction subset, maybe 20 stars. Any could be source, but signal duration, 72 seconds. Beam narrow, source small diode, not stellar, not planetary. If artificial, transmitter moved out of beam. Earth rotation carried Big Ear out of beam, 72 seconds. Matches beam width and rotation rate. Never returned to exact same spot, never seen again. Many hypotheses, none proven. Interstellar scintillation, satellite interference, computer glitch, comet impact on Earth hydrogen cloud, alien transmission, no consensus. 3, my Atlas coincidence weak. 9 degrees substantial angular distance. 48 years, substantial time gap. Trajectory would place comet far from Earth in 1977. Many astronomical units away, no mechanism for signal. Coincidence, likely random. Sagittarius toward galactic center. Many interstellar objects come from that direction. Galactic disk orientation, no special significance, noted for completeness, scientifically weak, publicly interesting, correlation, not causation, connection implausible, spacecraft imaging, captured comet evolution. Hubble, July 21st, showed compact coma with dust plume. Gemini South, August 27th, showed tail development. ExoMars, October 3rd, showed fuzzy dot with coma visible. Punch, October 14th, showed extended coma in coronagraph. Each image, different distance. Different activity level, different viewing geometry. July distance, 446 million kilometers. Activity moderate, tail barely visible. August, distance closer. Activity increasing, tail 0.5 arc minute. October distance minimum at Mars. Activity high. Coma brightest, tail extending. Nucleus surrounded by thick atmosphere of gas and dust. November reappearance will show post-perihelion state. Maximum heating past. Water activity might surge. Carbon dioxide depleted from outer layers. Composition shift. Brightness behavior. Tail structure. All change after perihelion. Every comet follows pattern. Inbound and outbound asymmetry. Pre-perihelion activity different from post-perihelion. 3. Atlas, no exception. Natural evolution, predictable physics. Measurements will confirm. Observation scheduled. Amateur and professional. Worldwide network, southern hemisphere favored. Northern observers see it low. Latitude matters. Timing matters. Weather matters. But somebody will catch it. Data will accumulate. Composition evolution will map. Final answer will crystallize. Orbital mechanics sealed the conclusion. Energy positive. Velocity exceeds escape velocity at all distances. Trajectory hyperbolic. No return, one pass, one observation window. After March 2026 at Jupiter, outbound journey continues. Distance increases. Brightness fades. Telescopes lose it. Gone. Back to interstellar medium. Next encounter unknown. Galaxy rotation carries it. Relative velocity to Sun 61 kilometers per second. 220,000 kilometers per hour. 1.9 million kilometers per day. 700 million kilometers per year. Distance to nearest star 4.2 light years. 40 trillion kilometers. At current speed, 68,000 years to nearest star, but trajectory not aimed at Proxima, aimed elsewhere. Random direction, random target. Billions of years drifting, chance encounters with other systems. Low probability per year, high probability over billions of years. How many systems visited before ours? Unknown. How many after ours? Unknown. Interstellar wanderer. Eternal voyage. No destination, just motion. Just time. We caught one moment, 4 months of close observation. July through November, peak activity October, perihelion October 29th, Venus flyby, November 3rd, reobservation, November through December, Jupiter flyby, March, gone by mid-2026, window closing, science extracted. Questions answered, new questions raised. The Venus pass itself unremarkable except for timing, 97 million kilometers. Not close, not unusual. Many comets pass Venus at such distances. Only reason it matters is the comet came from another star. That makes every measurement precious, every data point irreplaceable. The sample size, 1. This composition unique. This object special. Venus distance just another number in the trajectory table, but the context transforms it. We measured an interstellar visitor during planetary flyby. We recorded its composition during active phase. We documented its structure during maximum brightness, November 3rd milestone and 4-month campaign. Not dramatic moment, not crisis point, just another measurement opportunity, just another data collection point. Science proceeds incrementally. Every observation adds knowledge. Venus pass added data. JUICE observations will add more. Jupiter pass will add more. Each piece fits puzzle. Each measurement refines models. Each spectrum constrains formation scenarios, accumulated evidence. Convergent conclusions, interstellar visitor, natural object, unusual composition, carbon dioxide rich, ancient, 7 billion years, thick disk origin, different chemistry than solar system, but natural chemistry, explainable chemistry, no technology, no aliens, just physics. Just chemistry, just time. Social media wanted aliens, mothership probes, surveillance, threat, drama, conflict, narrative. Scientists wanted data, spectra, images, photometry, composition, knowledge, truth. 2 different goals, 2 different standards. Social media thrives on speculation. Science requires evidence. Speculation cheap, evidence expensive, telescopes expensive, observing time limited, analysis rigorous, peer review harsh. Claims must withstand scrutiny. Data must be reproducible. Conclusions must follow from evidence. No shortcuts, no assumptions, no wishful thinking. 3 Atlas subjected to this process. Dozens of papers, hundreds of observations, thousands of spectra, every measurement checked, every calculation verified, every conclusion supported. Result consensus. Natural comet. Interstellar origin. Unusual composition. Explainable by formation environment. No evidence for technology, no evidence for intelligence, no evidence for artificial construction. Loeb argued otherwise. Published calculations, highlighted anomalies, suggested possibilities. Science debate continues. Evidence accumulates. Consensus strengthens. Natural explanation sufficient. Extraordinary claims require extraordinary evidence. Evidence for natural processes present. Evidence for technology absent. Standard remains. Burden of proof on extraordinary claim. Null hypothesis, natural origin. Alternative hypothesis requires stronger case. Case not made. Data fit natural models. Models fit physics. Physics explains observations. Circle closes. Question answered. 3 Atlas. Natural interstellar comet with unusual but explainable composition. Period. November 3rd came and went. Venus pass occurred. Distance 97 million kilometers. No drama, no surprise, no crisis. Comet continued trajectory. Velocity constant. Path predictable. Observations continued. Data accumulated. Science proceeded. Normal operation. The hype promised revelation. The hype delivered nothing because nothing dramatic happened. Nothing dramatic was going to happen. Physics determined the path. Gravity pulled the comet. Sun heated the nucleus. Ice sublimated. Gas escaped. Dust lifted. Coma formed. Tail extended. Standard cometary physics. Same as every comet. Same as solar system comets. Origin different. Composition different. Age different. But behavior same. Processes same. Physics same. Laws don't change for interstellar visitors. Gravity works same. Thermodynamics works same. Radiation works same. Chemistry works same. 3. Atlas followed rules. Obeyed laws. Behaved predictably. That predictability killed drama. Drama requires surprise. Science requires predictability. You want surprise. You want mystery. You want unknown. Science wants known. Once measured. Once explained. 3. Atlas explained. Mystery solved. Composition weird but natural. Trajectory unusual but predictable. Activity strong but standard. Object interesting but comprehensible. That's the victory. That's the achievement. We saw interstellar visitor. We measured its chemistry. We understood its nature. We added to knowledge. That's what November 3rd means. Not mothership, not probes, not aliens, just successful science, just good data, just incremental progress toward understanding cosmos. Final numbers matter. Carbon dioxide to water ratio 8:1, highest measured except one outlier. Nickel emission 4.6 grams per second, no iron counterpart. Coma radius 348,000 kilometers, 54 Earth diameters. Nucleus diameter uncertain between 320 meters and 46 kilometers, most likely less than 1 kilometer. Mass minimum 33 billion tons, maximum unknown. Perihelion distance 1.36 AU, Venus distance 0.65 AU. Mars distance 0.19 AU. Earth distance 1.8 AU. Jupiter distance 0.36 AU. Velocity 68 kilometers per second at perihelion, 61 kilometers per second in interstellar frame. Age possibly 7 billion years. Origin possibly galactic thick disk. Discovery July 1st. Perihelion. October 29th. Venus past November 3rd. Reappearance November 11th. Earth closest December 19th. Jupiter closest March 16th, 2026. Final observation probably mid-2026. Then gone forever. Measurements preserved. Data archived. Papers published. Knowledge gained. Object understood. Mission accomplished. The lesson cuts through noise. Interstellar objects exist. They visit solar system regularly. We detect them occasionally. 3 confirmed so far. More coming. Vera Rubin will find them. Other surveys will find them. Detection rate increasing. Technology improving. Sensitivity increasing. Catalog growing. Each detection teaches. Each composition informs. Each trajectory constrains models. Galactic environment. Star formation history. Molecular cloud chemistry. Planetary system formation. Comet evolution. Radiation processing. All connected. All informed by samples. 3I Atlas 1 sample. Unusual sample. High carbon dioxide. Low water. Ancient age. Different origin. Tells different story than solar system comets. Adds data point. Expands parameter space. Enriches understanding. That's the value. Not aliens, not technology, not drama, just knowledge, just science, just understanding. Venus past November 3rd, 2025, marked moment in this process. 1 date and 4-month observation campaign, 1 distance measurement in trajectory catalog, 1 data point in growing database, stripped of hype, reduced to facts, measured in numbers. 3, Atlas reveals what we hope to find. Evidence of other places, evidence of other times, evidence of different chemistries, evidence that our solar system, one example among many, evidence that our corner of galaxy not special, evidence that cosmos diverse, ancient, full of wanderers. We caught one wanderer. We measured it. We understood it. We let it go. The hype fades. The data remains. The knowledge grows. That's all that matters. That's all that lasts. December observations begin soon. Comet reappears. Post-perihelion phase. Activity evolution. Composition change. Brightness decline. All measured. all recorded, all analyzed, Jupiter observations, March, final act, last measurements, best spacecraft data from JUICE, then farewell, then silence, then memory, then archive, then papers, then citations, then history. 3-eye atlas becomes reference, example, comparison, standard, future detections measured against it, carbon dioxide dominance threshold, nickel emission pattern, trajectory class, size range, all benchmarked by 3-eye atlas, first detailed interstellar comet study. 2-eye Borisov previous, 3-eye atlas improved, better instruments, longer observation, more spectra, deeper understanding. Next one will improve again, better preparation, better coordination, better analysis, knowledge compounds, science progresses. Each visitor teaches. Each measurement matters, each spectrum precious. November 3rd, Venus passed one piece of larger story. Story of interstellar visitors, story of cosmic chemistry, story of galactic evolution, story of our place among stars, story written in numbers, story told by telescopes, story confirmed by physics, story of 3-eye atlas, interstellar comet, natural object, unusual composition. November 3rd, flyby, 97 million kilometers from Venus, documented, measured, explained, without hype.